Welcome to the Deck Dive, brought to you by Aegis School of Data Science and AI.
hmm
Aegis is India's first school to launch a PGP in data science, business analytics, and AI. Since 2015, Aegis has been collaborating with numerous startups and leading firms,
Right. Quite a history there.
offering programs in data science, business analytics, AI, generative AI, AI agents, and machine learning and deep learning. Welcome, everyone, to the Deep Dive. This is where we take a whole stack of information, and pull out the bits that really
Got
matter.
it, Mel.
Today, we're diving deep into something you're probably hearing more and more about, AI agents.
Oh, yeah, definitely a hot topic.
You shared some really fascinating material, what they are, how they actually work, what they can do. Our goal today is to, well, unpack it all.
Right. Give everyone a clear picture of this field because it's moving fast.
Exactly. So your sources, they cover the definition, key features,
Mm.
the differences between agents, assistants, bots.
Yeah, how they function, different types, the pros and cons, benefits, challenges, and some real-world examples, too.
Perfect. So the mission for everyone listening. By the end of this, you'll have a solid grasp of AI agents, their potential, and, the key things to keep in mind.
Let's do it.
Okay, let's start right at the top. What exactly is an AI agent? The term feels, well, a bit vague sometimes.
Yeah, I get that. So at its core, an AI agent is basically a software system. It uses artificial intelligence to go after specific goals, complete tasks for a user.
Okay, simple enough.
But, and this is the key thing the sources point out, what's really changed things is generative AI and these big foundation models.
Right, the LLMs and things like that.
Exactly. They've given these agents some, frankly, pretty impressive capabilities.
Such as, what specifically makes them different now?
Well, the material really highlights reasoning, planning, and memory as key. And maybe the biggest one, a degree of autonomy.
Autonomy, meaning they can act on their own.
Pretty much. Make decisions, learn from those decisions, adapt over time. They're not just waiting for you to tell them every single step.
So they're operating beyond just a fixed script or set of instructions.
Precisely. And another big thing the sources emphasize is their multimodal capacity.
Multimodal, meaning?
They can handle different types of information at the same time. Text, voice, video, audio, even computer code simultaneously.
Wait, all at once?
Yeah. Think about what that means for understanding the context of a situation.
Wow, okay. Processing all that together,
Right.
that really changes how you might interact with something. It's not just one input channel anymore.
Exactly. So maybe it's listening to you, looking at an image you shared, and reading some text all at once to figure out the best next step.
Right.
And that better understanding, that fuels their ability to converse more naturally, reason through problems more effectively, learn with more depth, and, yeah, make better decisions.
Okay.
The material also mentions how they learn over time, so they get better. And importantly, they can even handle things like making transactions or managing complex business processes.
It sounds like we're heading towards almost like digital colleagues in a
Yeah.
way.
That's a good way to put it, actually. The sources even talk about them collaborating with other agents.
Multiple agents working together.
Yeah, tackling really complex workflows. Imagine a team of specialized AIs coordinating to achieve some big goal.
Okay, that collaboration part.
Yeah.
That's really interesting. Now, you mentioned key features. Let's dig into that essential toolkit. What makes them tick?
Right. So beyond just, thinking and doing, the sources lay out a few core components. Let's start with reasoning.
Okay.
It's not just processing data. It's using logic, using information to actually draw conclusions, make inferences, solve problems.
So finding patterns, understanding the why.
Exactly. Analyzing data, identifying patterns, making informed decisions based on what it's seeing or knows, understanding the why, not just the what.
Got it. So it thinks. Then what?
Then it needs to act. That's the next key feature. Taking action, performing tasks based on its decisions or plans or whatever input it gets.
And that could be digital.
Or
Physical.
both, potentially. The sources give examples like sending a message, updating a database that's digital. Or, for embodied AI, it could be a physical action.
Okay, so think, then do. Makes sense. What else is in the toolkit?
Observing. It needs to gather information, right?
Yeah.
Perceive its environment or the situation.
How does it do that?
Through things like computer vision seeing, understanding images, natural language processing, understanding text and speech, maybe sensor data, depending on the agent. This constant observation is crucial for it to understand what's going on and make good decisions. It needs that input.
Makes perfect sense. You can't react intelligently if you don't know what's happening.
Then there's planning. This isn't just reacting in the moment. It's developing a strategy, a sequence of steps to reach its goal.
Okay, so thinking ahead.
Yeah, identifying the steps, evaluating different options, anticipating what might happen next, potential roadblocks.
So it's actually strategizing, not just responding to the last thing that happened.
Precisely. And another one we touched on, collaborating. Working effectively with humans or other AIs.
Which seems increasingly important for complex tasks.
Definitely. It requires communication, coordination, integrating different viewpoints.
Yeah.
Teamwork, like you said earlier, even for AI.
Teamwork makes the dream work, even for silicon brains.
Exactly. And finally, self-refining. This is huge.
Meaning it gets better on its own?
Yeah. Learning from experience, adjusting based on feedback, continuously improving its performance. Machine learning is key here, obviously.
So it learns and adapts.
It means the agents we have now are probably, way less capable than what we'll see even in a few years. It's constantly evolving.
Okay, they're evolving. That leads to my next point. There's a lot of terminology flying around. Agents, assistants, bots. It gets confusing. Can we clear that up?
Yeah, absolutely. And your sources have a helpful way to break it down, looking at purpose, capabilities, and interaction style.
Okay, let's use that. Start with AI agents again. Purpose.
Their main purpose, according to the table, is autonomous and proactive task performance. Key words. Autonomous, proactive, they don't just wait.
Right. And capabilities.
They can handle complex, multi-step actions. They learn and adapt. And crucially, they make decisions independently to reach their goals.
That independence, that seems like the big differentiator. Interaction style.
Proactive and goal-oriented. They're actively working towards something.
Okay. Now contrast that with AI assistants, like Siri or Alexa, maybe. Purpose.
Primarily, assisting users with tasks, more of a supportive role.
Okay. Capabilities.
They respond to requests, provide information, complete simpler tasks. They might recommend actions.
But the user decides.
Exactly. The final decision rests with the user. Their interaction style is mostly reactive. They respond when asked.
Got it. Reactive support. And finally, bots, like a simple customer service chatbot.
Yep. Their purpose is automating simple tasks or conversations. Think FAQs, basic interactions.
Capability.
Usually follow predefined rules or scripts, limited learning, basic interactions. They're also reactive, triggered by commands or specific inputs.
So if we boil it down, the key difference really is autonomy.
That's what the sources hammer home. Agents have the most autonomy, assistants less, bots very little. That ability to operate independently towards a goal is what sets agents apart.
Okay, much clearer now. We know what they are, what makes them different, but how do they work? Let's peek under the hood.
Right. The mechanics.
Yeah.
The material you shared digs into this. It talks about defining an agent's role, its personality, even its communication style.
You give it a persona, like creating a character.
Sort of, yeah. A persona helps it maintain consistency, interact appropriately for its role. And interestingly, the sources say this persona can actually evolve with experience.
Whoa, so it kind of develops its own digital style.
In a way. Then there's memory, which, as you'd expect, is critical for learning.
Makes sense. What kind of memory?
The sources detail a few types. Short-term, for immediate stuff, what's happening right now. Long-term, for historical data, past conversations.
Yeah.
Episodic memory, for specific past experiences.
Yeah.
And even consensus memory, which is like shared knowledge if multiple agents are working together.
Yeah. So it's not just reacting to the now, it's drawing on history and shared knowledge.
Exactly. All these allow it to keep context, learn from the past, and adapt better. It remembers what worked, what didn't.
Got it. Memory is key. Then it mentions tools. What are tools for an AI agent?
Think of them as functions or external resources it can use to interact with the world or get things done.
Like what?
Could be accessing a database, analyzing data, maybe controlling some software, or even a physical device in some cases. They're how the agent does stuff beyond just processing information.
So tools give it reach, the ability to act.
Precisely. And there's this idea of tool learning, too. The agent has to learn how to use the tools effectively, which one to use when, how to use it properly.
So it's not just having the tools, but knowing how and when to deploy them.
Exactly. And at the heart of all this, the model.
The large language model, the LLM.
Yeah, that's the brain, so to speak. It provides the core ability to understand language, reason, and decide on actions. The memory, the tools, they all support and enhance what the LLM can do.
So the LLM is the engine, and the rest is the chassis and the controls.
That's a decent analogy, yeah.
Yeah.
The LLM gives it the raw processing power and understanding.
Okay. Definition, features, differences, mechanics. Check. Now, what kinds of AI agents are out there? Seems like there could be different flavors.
There are. Your sources break it down in a couple of main ways. First, based on how they interact with us.
Okay.
On one hand, you have interactive partners, sometimes called surface agents. These are the ones you'd typically interact with directly.
Like a customer service helper
Uh,
or maybe something in education?
exactly. Customer service, healthcare, education, even science. They give personalized support, have conversations, Q&A, chat, general knowledge. Usually you trigger them with a query.
So they're user-facing, responding to requests. What's the other type?
Autonomous background processes, or
Yeah.
background agents. These guys work behind the scenes,
Doing what?
automating routines, analyzing data, optimizing processes, maybe spotting potential issues proactively. Think workflow agents. They often run based on events or schedules, little or no direct human interaction needed.
Okay, so visible interactive ones and invisible process automating ones. What's the other way to categorize them?
By the number of agents involved. Single agent versus multi-agent systems.
Single agent sounds straightforward.
Yeah, one agent working independently towards its goal, uses tools as needed. Best for tasks that are pretty self-contained, don't need collaboration, and typically uses just one foundation model.
One brain, one mission. What about multi-agent? Sounds more complex.
It is multiple agents working together, maybe collaborating, maybe even competing sometimes towards a shared goal or individual but related goals.
What's the advantage there?
You can leverage diverse skills. Each agent might be specialized. They can tackle much more complex problems together than one could alone.
Like a human team.
Exactly. The source mentions they can even simulate human social behaviors. And each agent in a multi-agent system could potentially use a different foundation model, one best suited for its specific job.
Wow, simulating social behavior. That opens up some interesting possibilities. And potentially some questions, too.
It definitely does. Which brings us to a pretty crucial question. Why should we care? Why should our listeners be interested in AI agents? What's the benefit?
Right, connecting it back. We all want to get things done faster, better, gain knowledge efficiently. How do agents help with that? Or what are the broader upsides?
Well, your sources point to several big ones. First off, efficiency and productivity gains.
How so?
You can divide tasks among agents. They can work simultaneously. They can automate all those repetitive, time-consuming tasks,
Yeah.
freeing up humans for more strategic stuff.
Okay, more output, less drudgery. Sounds good. What else?
Better decision-making. When multiple agents collaborate, you get diverse perspectives, maybe even reasoned debate between them.
Agents arguing.
Sort of, yeah. Leading to potentially more robust decisions. They can adapt to changing situations quickly, too.
Like a super-powered, always-on committee.
Huh. Maybe a more efficient one. Then there's just enhanced capabilities overall.
Meaning?
They can tackle really complex problems by combining strengths. They use natural language. They use tools to interact with the world. And remember, they learn and self-improve. Their capabilities grow over time.
That cycle of improvement again.
Exactly. And finally, that social interaction and simulation aspect we mentioned.
Right, modeling complex behaviors.
Yeah, it could be really valuable for understanding social dynamics, maybe even predicting outcomes in certain situations.
Okay, lots of potential benefits. But we need the balanced view. What about the downsides? The challenges? Where should we be cautious?
Absolutely crucial. And the sources are clear about limitations. One area is tasks needing deep empathy or emotional intelligence.
Like therapy or maybe delicate negotiations.
Exactly. Complex human social dynamics, nuanced interactions. AI struggles there. It doesn't feel or understand emotion in the human sense.
Makes sense. That human touch is hard to replicate. What else?
Situations with high ethical stakes. Law enforcement, certain healthcare decisions, judicial stuff.
Why the concern there?
Agents operate on data and algorithms. They don't have a human moral compass, nuanced ethical judgment built from life experience. Big potential for problems if not handled extremely carefully.
So areas requiring deep ethical reasoning are tricky.
Very. Also, highly unpredictable physical environments.
Yeah.
Surgery, construction sites, disaster response. Places where things change fast and unexpectedly, requiring complex motor skills and real-time adaptation. AI can struggle when the real world gets messy.
The clean digital world versus the unpredictable physical one.
That's a good way to put it. And finally, resources. Building and running sophisticated AI agents takes a lot of computing power and, well, money.
So it might not be accessible to everyone or for every project.
That's a potential barrier, yeah. The cost could be significant, especially for the most advanced systems.
Okay, benefits and challenges noted. Let's make this concrete. Where are we actually seeing AI agents used right now? Give us some real-world examples.
Sure. The sources list quite a few. A big one is customer agents.
Enhancing customer service.
Yeah, going beyond basic bots, creating personalized experiences, understanding needs, answering complex questions, resolving issues, making recommendations
Yeah.
across different channels like web, mobile, maybe even in stores.
More proactive and tailored support.
Exactly. Then there are employee agents,
For internal use.
right? Streamlining internal processes, managing tasks, answering employee questions, helping with things like content editing or translation, basically boosting internal productivity.
A virtual assistant for the workforce.
Kind of, yeah. Creative agents are another fascinating area,
Helping with creative work.
assisting with generating content images, text, ideas, supporting design, writing, personalization, augmenting human creativity, not necessarily replacing it.
Interesting. Amplifying creativity.
Then data agents, doing complex data analysis, finding insights, acting on those insights, and importantly, checking for factual accuracy, turning data into action faster.
Making sense of all the data we have.
You got it. Code agents are helping developers,
How?
speeding up software development,
Yeah.
generating code, suggesting improvements, assisting in real time, making development faster, and potentially improving code quality.
A coder's co-pilot.
Exactly. And finally, security agents.
For cybersecurity.
Yep. Strengthening security, spotting threats, mitigating attacks, speeding up investigations, adding another layer of defense.
So really across the board, customer-facing, internal, creative, data, coding, security.
It's becoming quite widespread, touching many different fields and functions. The potential is definitely starting to be realized.
So wrapping things up, as we've explored, AI agents are clearly more than just, souped-up chatbots. They seem to be a pretty significant step towards systems that can truly operate on their own reasoning, planning, acting, even collaborating.
That's right. From automating the simple stuff to tackling really complex analysis, the potential impact across pretty much every industry looks, well, immense.
And thinking about the different types, those interactive partners versus the background processes, the single versus multi-agent systems,
Yeah.
you can really start to picture how they might weave into our work and lives.
Mm-hmm. Whether it's making your own workflow smoother, finding those hidden gems in data, or even getting a hand with creative projects, the possibilities are genuinely fascinating.
Definitely. So here's a final thought to leave everyone with, building on that multi-agent idea. Considering their ability to simulate social behaviors, maybe even show emergent properties, what are the long-term implications, not just for machines, but for how we understand collaboration and intelligence itself, maybe even in us humans?
That's a deep one to ponder. How does seeing intelligence emerge in silicon change how we view our own? Lots to think about there.